Hello everyone. I am discussing about the prime numbers in this video. Prime numbers are natural numbers greater than 1 that are divisible only by 1 and themselves with no other positive divisors. In other words, a prime number has exactly two distinct positive divisors, 1 and the number itself. Examples of prime numbers include 2, 3, 5, 7, 11, 13, and so forth. It may be noted that 1 is not a prime number as well as 1 is not a composite number also. So, prime number started from 2. 2 is a prime number which is even. 2 is the smallest prime number. Okay. These points to be remembered because questions regularly comes on these points from prime number. Okay. How do we find prime numbers? Prime numbers between 1 and 100 we can find easily using the sieve of Eratosthenes method. Here's how it works. First of all, we have to create a list numbers from 2 to 100. So, I am making this list here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Next, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. I am seeing the full process. Forty-one, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. 61, 62, 63, 64, 65, 66, 67, 61. Okay. 7, right? 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90. 91, 92, 93, 94, 95, 96, 97, 98, 99. So the first step is to write the list of numbers. We are in process to find out the prime numbers in between 1 and 100. So we have to write 1 to 100 in this manner. Okay. Already I told that 1 is neither prime nor composite. So it is removed from this table. Now start with the first number in the list 2, which is a prime number. So 2 is the prime number. We box it. Okay. After that, cross out all multiples of 2 except for 2 itself from the list. If we read out the table 2, then we get the multiple of 2, and we know that all even numbers are the multiple of 2, or all even number divisible, exactly divisible by 2. So all the even number in this list are not a prime number. So this should be crossed out. Okay. These are the even number. Similarly, these are all even numbers. So this to be crossed out. Okay. The second step is cross out all the multiples of 2 from the list. Then move to the next number in the list that has not been crossed out. This is 3. So this will be the next prime number. So we put it in a box. Okay. Cross out all multiples of this prime number from the list. If we recall the table of 3, then the multiple of 3 to be crossed out. 3 ones are 3. This is a prime number. 3 to the 6. This is not a prime number. Already crossed it as it is an even number. 3 3s are 9. So 9 to be crossed out. 3 4s are 12. Already crossed. 15. 3 5s are 15. 18 already crossed. 3 7s are 21. 24 already crossed. 27. 30 already crossed. 33. 36 already crossed. This is 37, right? 39. 42 already crossed. 45. 48 already crossed. 51. 54 already crossed. Then 57. These are all the multiple of 3. Then 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, lastly in this list 99. These are all the multiple of 3. So these are to be crossed out. After that, the number 5, it is the prime number. So multiple of 5 to be crossed out. We know the multiple of 5 are the first digit 5. So these are to be crossed out. Okay. And also the multiple of 5 have unit digit is 0. So this is to be crossed out. It is already crossed out because these are the even numbers. Okay. So we have to find the next number which is not crossed after 5. We are seeing that 7 is not crossed. So 7 is a prime number. Then we have to cross out the multiple of 7. 7, only keep it 7. Then other multiples of 7 to be crossed out. So 7 to the 14, 21, 28, 35, 42, 49. 49 is the multiple of 7, so it should be crossed out. 56, 63, 70, 77, 84, 91. Right? Then 98 already crossed out. So after 7, the immediate remaining number which has not crossed, this is 11. So put it in a box. This is a prime number, and 11 2s are 22, 3s are 33, 4s are 44, 5s are 55, 6s are 66, 7s are 77, 8s are 88, 9s are 99. Already all multiples within 100 of 11 are crossed out. So we then go to the next number which is prime. This is 13. Put it in a box, and the multiple of 13 to be crossed out, left only 13. Okay. So 13 2s are 26, 39, 39, 52, 65, 78, 91. Within 100, these are the multiple of 13 and all are crossed out. After that, the number which is not crossed out, this is 17. So 17 is a prime number. We put in a box. Then we have to cross out the multiple of 7. 17 2s are 34, 51, 68, 68, 85. These are the multiple of 17 within 100. So after that, the number come 19, which is prime number. Since it is not till crossed out, so multiple of 19, 38, 57, 76, 95. All are crossed out. Okay. After that, we get 23. 23 is the prime number. 46, 69, 92. Okay. Then what we get? 29 is a prime number. 58, 87. Okay. Then 31. Then if we check, we get 37. Then we get 41. Then we get 43, 47, 53, 59, 61, 67. These are all the prime numbers. 71, 73, 79, 83, 89, and lastly 97 within 100. 97 is the prime number. So if we count within 1 to 50, there are how many prime numbers? See here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So within 1 to 50, we get the 15 numbers prime number. Okay. Similarly, if we count within 1 to 100, there are how many prime numbers? There are 25 prime numbers. So it may be noted that the numbers of prime number present in each interval, in each equal intervals, are not equal, because within 1 to 50 there are 15 prime numbers, but 1 to 100 there are 25 prime numbers. So within 51 to 100 there are only 10 prime numbers, right? So from 1 to 50 there are 15, but from 51 to 100 there are 10. So these are not equal to each other, but the range is equal. Here is also within 50 numbers, and here is also within 50 numbers. So the presence of prime numbers are not even in same intervals. It is to be noted. So here I have discussed about how do we find the prime numbers in between 1 to 100. After completing this process, the number that remain uncrossed are the prime numbers between 1 and 100. And find that the uncrossed numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. This number to be read several times so that you can recognize easily which one is prime number within 1 to 100 without calculation. Okay, it is very essential to distinguish prime numbers at least within 1 to 100. So you should practice it. This table also do practice several times. After that, how do we test whether a given number is prime or not? If a number is given arbitrary to you, then how do you test the number whether it is prime or not? For this, we can use various methods. One simple approach is the trial division method, which involves checking whether the number is divisible by any integer other than 1 and itself. Here is a step-by-step guide. Start with the number you want to test for primality. Check if the number is less than 2. If it is not prime. Check if the number is divisible by 2. If it is and the number is not 2 itself, then it is not prime. That is, all even numbers are not prime number. If the number is not divisible by 2, start checking divisibility by odd numbers starting from 3 up to the square root of the number. This is because if a number is not prime, it must have a factor less than or equal to its square root. If any of these odd numbers divides the given number evenly, then the number is not prime, otherwise it is prime. For understanding these steps, I am going to discuss about an example on it. If n equal to 10 and you are testing divisibility by 2, 10 divided by 2 is 5 with no remainder, so 10 is not a prime number. And if n equal to 11 and you are testing divisibility by 2, 11 divided by 2 gives a quotient of 5 with a remainder of 1. Similarly, if you test divisibility by any other integer up to the square root of 11, none will divide 11 evenly. Therefore, 11 is a prime number. Understand? One important theorem related to prime numbers is the fundamental theorem of arithmetic. It is very important theorem. It states that a number can be represented by the multiplication of its prime factors. This theorem states that every integer greater than 1 either is a prime number itself or can be represented as a unique product of prime numbers up to the order of the factors. Once again, I am repeating, the every integer greater than 1 either is a prime number itself or can be represented as a unique product of prime numbers up to the order of the factors. Understand? let 6. Is 6 a prime number? No. So 6 can be represented by its prime products. 1 is not prime number. So it's 2 into 3. Okay. In other words, the fundamental theorem of arithmetic asserts that every integer greater than 1 can be expressed as a product of prime numbers. What I told already can be expressed as a product of prime numbers in exactly one way, except for the order of the factors. This theorem highlights the fundamental role of prime numbers in the structure of the integers and is a cornerstone of number theory. It is very important theorem in arithmetic, fundamental theorem of arithmetic, that is, it is known as fundamental theorem of arithmetic. Next theorem of prime number theorem. It states that the number of prime numbers less than or equal to a given number n is approximately n by log n, where log n represents the nature of logarithm of n, natural logarithm of n. With the help of this theorem, we can find out the numbers of prime numbers for a range of number. For example, let's consider finding the approximate number of prime numbers less than or equal to 100. Using the prime number theorem, for n equal to 100, log 100 is approximately 4.605. So the approximate number of prime numbers less than or equal to 100 is 100 by 4.605 equals to 2.69. Therefore, according to prime number theorem, there are approximately 21 prime numbers less than or equal to 100. But already what we see that there are 25 prime numbers within 100. So, is it wrong? This theorem approximately states that 21 prime numbers are within 100. So, it is mismatched with the find out number within 1 to 100, that is 25 prime numbers. But 100 is a small number. If we elevate this number to a big number, then this rule will be more accurate. Okay. This approximation becomes more accurate as n becomes larger. The prime number theorem provides valuable insights into the distribution of prime numbers and helps mathematicians understand their density among the positive integers. Understand? So it is the approximate value and it will be more accurate for larger numbers. Okay. To find out how many prime numbers there are exactly within 100, we can simply count them. Therefore, for 100 is a small number, so How many prime numbers are there within 100? We have to count. No theory is there to find out the exact numbers of prime numbers in between 1 to 100. So we have to count and we get 25 prime numbers within 100. Now, what is twin prime numbers? The term twin prime numbers represents or refers pairs of prime numbers that have a difference of 2. In other words, they are prime numbers that are adjacent to each other with only one even number between them. For example, 3, 5. 3, 5 are the twin prime number. In between 3 and 5, there is only even number and only an even number, that is 4. Similarly, in between 11 and 13, there is an only even number, this is 12. And for 29, 31, there is also an even number, 30, in between 29 and 30. So, 3, 5, 3, 5, 11, 13, 29, 31 are the examples of twin prime pairs. Understand? Now, coprime numbers, also known as relatively prime numbers, are two integers that have no common positive integer factors other than 1. In other words, their greatest common divisor is 1. For example, the number 15 and 28 are coprime because their only common factor is 1. The GCD, greatest common divisor, of 15 and 28 is 1. Similarly, the numbers 8 and 21 are coprime because their only common factor is 1. The greatest common divisor of 8 and 21 is 1. However, it is important to note that even if two numbers do not have any common factors greater than 1, they might not be coprime if one or both of them are negative. For example, while minus 15 and 28 have no common factors other than 1, they are not considered coprime because at least one of them is negative, right? For coprime numbers, you have to remember this point. They might not be coprime if one or both of them are negative, right? So in this video, we have seen what is prime number, how do we find the prime numbers in between 1 and 100, how many prime numbers within 1 to 50 and 1 to 100, and we noted that the distribution of prime numbers is not even. How do we test a number whether it is prime or not? The process has been described. After that, the two important theorems related to prime number have been discussed in this video. These are fundamental theorem of arithmetic as well as prime number theorem, right? Among these two, our interest to be primarily on fundamental theorem of arithmetic. Okay, the prime number theorem finds the approximate number of prime numbers. Okay, after that, twin prime numbers and the coprime numbers have been discussed with examples. Okay, I hope you are understand about the prime number, and you are now confident to attempt any questions on prime number. Thank you very much. Thank you to all.